Hello, my lesson is over the calculus concept of curve sketching, but rarely do they ask the students to sketch a curve. They ask them to look at a graph and describe features using the derivative and sometimes the second derivative. The lesson I'm going to do is mainly going to be on the website app Desmos, so I'm going to go there first, desmos.com. And Desmos is a graphing calculator, so the students could push this button here and go to the graphing calculator. They can also go to a for-function or scientific. But for teachers, they have the teacher.desmos.com, so we can do activities. I am already signed in, and I come over here and click on Custom to show the activities that I have. We're going to begin the lesson with something the students should already know how to do, but I want to review it, and it also gives them an opportunity to learn how to use the Desmos website. So I wanted to give them something that they kind of knew to start this out. The parent functions is the first one I'm going to use. This is one that I created myself, and it is a matching game. So I click on it and I go here. Now once I have it set up, I can create a class code, which I have already done. Now if I view dashboard, this comes up, and I can have students go to student.desmos.com. So I'm going to do a little split screen here, and I'm going to go into another web browser. Let's type this in, student.desmos.com. And it's taking a few seconds here. And then the students can enter their class code 56F space WYG, join. And for class, I will have the students sign in with Google, since all of my students will have a Google account with the school. But I'll go ahead today and go with continue without signing, and I will put my name and then say go. So here it gives me the activity. On the other screen, it is showing me what is happening over here, and I can have all of my students on the dashboard here, and I can be watching to see the progress. So what we're doing is we're having the students match up the graph to the equation. So I'm just going to do it this way. They may have a different process. I'm going to move all of the equations across the top here. And I'll just move this one right here. Now I'm going to do this the quick way, because ideally they would just know what these graphs look like because they've studied this in pre-calculus. So we're going back to Algebra 1, pre-calculus, Algebra 2. So for example, x squared is the parent function for the quadratic, so it's right here. If they do not remember, then they can try some other things like looking at the graph and maybe plugging in some x values, but we would rather them just know it. And they can click on the graph here to make it bigger so they can actually see it a little better, and then x that out. So real quickly, I'll match these up. The square root of x is right here. This is the natural log of x. This is 1 over x, and this is the sine of x. And you'll notice on the teacher dashboard, it is showing that I have a check here, and I've got all of these correct. So as I'm watching in class to see if the students are finishing and if they're getting them correct, I can go through each student and say, hey, you have a couple you need to look at, and give them a chance to go in and fix that. So that is the first, and then as they are finishing, I will be giving them a website to go look at, which is a YouTube video that I will pull up here now.
One of the key portions of the AP Calculus test is analyzing graphs, and especially analyzing graphs that aren't of the function itself.
Now, this is a YouTube video that I found of a calculus teacher going back over the characteristics that you can use the derivative to find. I'm not going to play it all right now, but the students will have this to kind of refresh their memory. At this point, they've already learned about derivatives and second derivatives, but they have learned how to do it analytically using the equations. Now we're taking it to graphically and visually. How do you tell what's happening? It's the next progression. We want to be able to look at the graph and see this. So after they have watched the YouTube video, to kind of get some insight and refresh their memory on what they have already learned, then they will go back to, and on Desmos, if you click this D right here, it takes you back to the home page, and I go back to custom. Alright, so now I would like the students to kind of explore a little bit, and I created this activity, this very short activity. It won't take them very long. And I'm going to go back over here and get rid of my YouTube and start a new one over here. Okay, so now this is graphs of derivatives, and I've already created the class code, so I'm going to say View Dashboard, and it comes up with this again. So I will go to Student, and it's already there. Enter the class code AWZ space 27E and join. And I'll have them continue without signing in, and I'll just go ahead and type my name again and go. So I've created a graph of a function, and for the function I have put in variables A, B, C, and D, and Desmos automatically gave me the option of making those variables sliders where we can change what the numbers are. So I have all four of those. So for example, right now A is 0.4, B is 1.9, C is 0, and D is 0. The blue graph is the derivative of A. And then the green graph is the derivative of the derivative, or the second derivative of f of x. So what I want them to do is just kind of look at this and just kind of try to move these around. So there's me moving D, and you see what happens. And here's C, it kind of stretches it out. And I just want them to kind of think about how is everything changing, all three graphs at once. And that's a lot to take in, so they may have to take a little bit of time on it. And I want them to take some time and just kind of look at this. But then the next thing they're going to do is go to the next page, and it says find the local maximum on f of x. Describe the derivative at that value. So they're going to go back, and so f of x is the red graph. I can't really see the maximum, so I'm going to move it until I can. Okay, right here I have a maximum, but it says to describe the blue graph, and here's what I notice is at the x value where I have the maximum, the blue graph is hitting the x-axis, and that is because the derivative has to change from positive to negative, which means if it's a continuous function like this, it has to have a zero slope, which would be a horizontal line there to show the slope at that point. And then I give them another question where it says describe the let's see, question 1. Question 2 says describe the approximate interval where f of x is concave up, and then look at the second derivative. So the students will go back to the first graph, and the red graph is the function, so it asks for concave. Let's go back. Concave up, which means just opening up. So the red graph right now is opening up from about here to forever. and the second derivative is green, and we see right where, about where that starts, right in here, that the second derivative is above the x-axis, which means it's positive. And that's what we're wanting them to see there. And then we ask them another question. What happens when you move slider D? So if we go back to the first one, when I move slider D, it just moves the original f of x or graph up and down. It has no effect on the other graphs because that constant, that's just a number at the end, that constant has a derivative of 0, so once you take the derivative it's no longer there, so it has no effect on the derivative or the second derivative. Just like c in front of the x has no effect on the second derivative, but it will have an effect on the first derivative and the function. All right, so we'll let them explore that for a little while, just kind of getting them back into what do all these mean. And then the matching activity that I want them to do, and I'm going to go ahead and open another tab here and go back over here. I click on D and go to Custom and go to Card Sort Match. So this matching activity is one that was actually already created by Desmos that I just copied and edited it there's a couple of things I didn't like about it. So one of the things teachers can do on here is find some activities, and there's some that you can't edit because of I guess the easy way to say it is they got a little fancy, and so there's things you can't do, but most of them you can download or you can copy and then save it as your own after you edit it. I'll show what I did to that. So I'm going to click on Create a Class Code here and go to View Dashboard. And I'm going to go back to Student, and there it is, and type in the class code. JC. All right, and we join, and then continue without signing in, and I'll put my name again. Now my original thought was to have first derivatives, second derivatives and the function, but it gets a little crowded on here. I'm going to actually make this full screen. And one of the changes I made was I made all of the functions blue just to give a little bit of help. And I made all of the derivatives red, and it says match each function to its derivative. So I'm going to put all the blue ones across the top. And there are 6 of them. So the first thing I'll look at is, I think I'll look at the 2 linear ones first. And I'm going to click on this so I can see it better. This is a line with a slope of 1, 2 over 3. So this has a slope of 3. So that means my derivative should be the horizontal line y equals 3, because the derivative is the slope. So anytime I have a line for a function, the derivative will be a horizontal line. So even without looking at this, I know that this one right here is my derivative for this linear function, because it's the only linear function I have left, so I know it's got to be a horizontal line. If I click on this, I can see the slope of this line is down 1, right 2, which is -1/2. And you can see that the graph right here is y equals -1/2. It's just down 1/2, and it's a horizontal line. The rest of these appear to be, since I have all linears for these are quadratics. So I want to focus on the maxes and the mins. So for example, this one right here, this function right here has a minimum at x equals 5. So we see this side is decreasing, which means the slope is negative. And this side is increasing, which means the slope is positive. So I'm looking for a derivative that starts out negative or below the x-axis, then crosses the x-axis at 5, and then becomes positive after that. So it must be crossing at 5. That's the first thing I'm going to look for. This is the only one where this line is crossing at 5, but I can see that this part of the derivative is negative because it's below the x-axis, and this part right here is positive. And so we go there. And same thing with this one. This one's going to have a derivative that is 0 at x equals 2. Right here at this local maximum. And so I'm looking for a slope of, I'm looking for a positive slope because it goes up, the graph goes up, so it's increasing, so it's positive slope, and then negative slope. So it means my graph will be above the x-axis, cross the x-axis at 2, and then below the x-axis. Now the only one that crosses the x-axis at 2 is this one right here, but you see it's positive and then hits the x-axis, then negative. Alright, this one crosses at -3, and this one right here, because this one has a maximum at -3, so it means its derivative will cross at -3. But I have to have positive because it's going up, whoops, and then going down, and then crossing at -3, and then this one, of course, is going to be the last one. It crosses at -5. Alright, if I go back to my dashboard, I can X this out, and it shows that the student, John Roy, has got all of them matched correctly for this first screen. Then I have other screens where I ask the students questions. So I will go ahead over here and go to, and I'm going to go ahead and make this half screen again. So it says, consider this function. Here's one of the cards from earlier. As it turns out, this was one of the original functions. Describe everything you know about its derivative. So we want them to say things like the derivative will be a linear function. The derivative will have a horizontal tangent at x equals 2. The graph of the derivative will cross the x-axis at x equals 2. And it will be positive to the left of that and negative to the right, and just everything they can think of to say. And then the teacher can monitor the entire class and see what answers they're putting on these to make any adjustments or corrections to the students' answers that need to be done. Then we have more slides. We have 3 others, same thing. Describe here's the derivative, and then it says describe everything you know about the original function, so we're working backwards. And then here are 2 functions. How are the derivatives similar, and how are they different? All right. Well, on this one, this one has a minimum, which will have a 0 slope there, and this one has a maximum, but they're both at -2. So both of these derivatives will be linear, and they will cross the x-axis at -2. All right. So this page is a reflection where we give the students a chance to discuss what process they are using to match these up. What are they looking for? And I just want them to say whatever they did. If they said, well, I matched the last one because it was the only one left, well, that's a proper strategy for this kind of thing. And that's always gonna be in play. But I want them to tell me exactly what they were thinking, so I can kind of analyze that and see, yeah, you've got that right. That's working for you. And then when they get done, they come to this page, and it says it gives them an opportunity to extend this by giving them more matching. And on this one, I did not change the colors, so they do not know which ones are the derivatives and which ones are the functions. So this is going to take them a little longer to match out. On the teacher side of this, when I get out of this screen right here, on the teacher side of it, as they are doing these, or when I write these out, I can, let me go to edit. I can edit the activity, but I can also create an answer key so it shows me right away, did they match these up correctly, and then if they didn't, we can make corrections to that. Finally, let me close this out. I will give my students an assessment where they work independently, and I give them a graph, and I just want them to answer some questions that are similar to what they might see on an exam. It says determine where, given f of x in the picture, and it gives them information about it, where f of x has a relative maximum. So they can look and see it. The answer is right here at x equals 2, and it does tell you at x equals 2 there's a horizontal tangent line. And I want them to say, though, because the graph is increasing and decreasing in an AP Calculus, you have to use the first derivative to answer this question, or they will not give you credit. So I want them to say, well, the first derivative is positive and then changes to negative at x equals 2, so that's why that is a relative maximum, and so on. And that concludes the lesson. I feel like it will take at least 2.5 days. I'll have to probably do this little assessment on the third day at the very least. Thank you very much.